So far, we have learned the indefinite integral, which is the integral of f of x times dx. And we also have learned the definite integral, which is the integral from a to b of f of x dx. And they are totally different things. The indefinite integral, which is actually the antiderivative, and this definite integral, which is a number, okay, it represents the signed area between the curve and the x-axis. Okay, but they are the writing, the notation are very similar, right? The notation are very similar, so they must have some relations between each other. Okay, so here is the fundamental theorem of calculus part 1. Of calculus part 1. So actually we have two parts for the fundamental theorem calculus, which says, suppose f is continuous on the closed interval from a to b, and f is one antiderivative and antiderivative of this lowercase f on this interval ab. Then we have the result that the integral from a to b of the lowercase f, which is equal to the antiderivative capital F evaluated at b minus the antiderivative capital F evaluated at a. So this part 1 tells you a way to calculate the definite integral using the antiderivative. So in other words, if you want to compute the definite integral from a to b, then you just need to find the antiderivative, one antiderivative for the lowercase f, then plug in b and plug in a, then take the difference. Then you will have the definite integral. So now let's look at some remarks for this definition. The first remark. So sometimes we write this one as f of x, then a long bar, which is called evaluate at a and b. Okay, so this capital F is the antiderivative of the lowercase f. So we use this symbol to denote f of b minus f of a. Okay. Two. But we know that we have infinitely many antiderivatives for the lowercase f, right? And the only difference between the antiderivatives are the constant. But when you do the evaluation for the antiderivative, you can see that this constant, you can just ignore this constant c. For example, if we add a constant, you can see at last it will be cancelled out. F of x dx, okay? So this is an antiderivative, right? This is the antiderivative. Capital F plus C, plus a constant. C is a constant. Then evaluate at A and B. This is the one antiderivative. So by the definition, it's equal to the value at B and A. Right? Then we plug in B minus plug in A. Then you can see the answer, f of B minus f of A. You see the C will be cancelled out. So in other words, if you want to evaluate the definite integral, you just need to find one antiderivative. Most time we will find using the antiderivative without any constant, because at last the constant will be cancelled out. So now let's look at one example, which is the integral from 1 to 3 x squared dx. Okay, so we need to find the antiderivative, right? We know that the antiderivative, how to find the antiderivative is equal to this one, right? We use the power rule, which is x to the 2 plus 1 divided by 2 plus 1, right? Then plus constant c. So this includes all the antiderivative, x cubed over 3 plus c. But we only use the part without any constant. So we use this one is the one antiderivative, then evaluate at 1 and 3. What does this mean? This means you plug in 3 cubed over 3 minus 1 cubed over 3. So this is equal to 9 minus 1/3, which is 26 over 3. Next, we will look at more examples.